See here, 10 plus 10. Again, here temp is incrementing 1. So 21 we are getting. 21 we are getting answer. Okay.
Okay.
Abstract class. What is meant by abstract class?
Something is very like abstract is matlab something is written, everything is written very short form.
Correct. Abstract class system Verilog declared with the keyword virtual is referred to as abstract class. Okay. Understood?
Hmm.
Earlier you have seen a virtual
Understood.
method, virtual, that is abstract class, which means that is not fully developed. That will be prototype. By in the
Yes.
derived class, we will develop that.
Okay.
An abstract class sets out to the prototype for the subclasses. For subclasses, it sets out to be prototype. Abstract class cannot instantiated. It can be only derived. An
Hmm.
abstract class can contain methods which are only a prototype and no implementation, just a method declaration. Okay.
Hmm.
Abstract class, derived class. Abstract class cannot be instantiated. It can only be derived. Abstract class syntax. Virtual class ABC. End class. That's all. No class definition. That's all. No implementation. That's what is called abstract class.
Okay.
Abstract class example.
Okay.
Instantiating virtual class. In the given below example, creating an object virtual class, an abstract class can be derived. Creating an object of a virtual class leads to compilation error. Understood? That is implementing,
Okay.
right? Something your object you are
Okay.
giving means you are implementing something that you shouldn't implement.
Hmm.
You should give prototype or virtual class packet, bit packet, end class, module, packet P equal to new. We will it will throw an error. Let us see what it will show. Cannot instantiate abstract class packet test bench, eighth line. This is wrong. That's what it is telling. Deriving virtual class. See, virtual class we can derive. Can we derive? Yeah, we can derive. Virtual class, this is a virtual class. Virtual class packet bit 30 down to 0 address. In class class extended extended packet extends packet. This is a child class, and here we are creating extended packet p equal to new. P can be implemented child class. Right. Then what value you will get? What is the value you will get in the display function?
10.
Correct. Address is 10. Okay. Virtual methods in system variable. Methods means what? What are the methods? Task and function.
If task and function.
Virtual function, virtual tasks. Base class is not virtual. So the base class method with virtual keyword. Virtual class. In the method inside the base class derived virtual keyword and calling method of base class which pointing to the extended class will be extended class method. Okay. It will point to the extended method. See inside the extended class. This class this function is displaying. This is child class, right? Class extended class is called child class, right? Extends base class. This is child class. This is displaying, though it is a virtual class, which means a virtual class, virtual methods can be virtual methods can be instantiated. The system Verilog scope resolution operator. What does it mean? The scope resolution used to specify an identifier uh, defined within the scope of the class. Define is used to specify the identifier defined within the scope of the class. Classes and other scopes can have the same identifiers. The scope resolution operator uniquely identifies the member of a particular class. The class resolution operator allows to access static members, class properties, and methods from outside the class, as well as the access to public or protected elements of the superclasses from the within the derived class. So these many advantages it have. See here ID. ID is present in packet class. Okay. That is with static. Though it is static, can we access if it is a static word? Static. Without scope resolution operator, can we access ID?
ID. No.
No, we cannot access.
Right. No.
Because of scope resolution operator, we can access. See, 2010. It is able to access. It will be possible with the help of scope resolution operator only. System Verilog external methods. In definition of method written outside the body of the class, then the method is called external methods. Okay. Class end class is completed. Method we are writing here outside the function. This is possible only with the help of scope resolution operator. Void pocket. This pocket is this class name. See, class name is pocket. This is also class name pocket. Here display function we are writing. This will be possible with the help of only scope resolution operator. What is this? See, we can able to access. In the task displays the declared inside the class with external keyword, and the definition of the task is written outside the here. External virtual task display and definition packet display. Okay. Okay. Task also we can declare outside. See here, here prototyping. Simply here he is prototyping. External with the external keyword virtual task display prototyping. The definition where he is giving with the class name here he is implementing outside the class. And we need to get the values. What are the values? We need to get address and data. Address comma data. Where they are in initial block. Okay. Packet equal to p equal to new, p dot address equal to 10, p dot data equal to 20, p dot display. These are all we need to execute. See 10 comma 20 executed. External function with arguments. Here see bit address comma data arguments are also it is there. So address comma t data comma t. Here some temporary address and data values. These are taking it, and we are passing 20 comma 30. We will see what will happen. It is throwing an error. What is wrong? Yeah, it will throw an error. External name method definition should match with the prototype declaration. Argument names do not match. Signature function packet dot display should match the corresponding prototype declaration at test bench. Okay, okay. Earlier, display packet display correct only. Address data external method.
अरे एक दिन में चलने तो ऐसे ऐसे किया करते थे प्लीज।
Okay, we will run this class. I'm not getting that. What is the difference? There is no difference. Yeah, it is success. It is coming. Earlier value, why didn't it come? I don't know. This one is working. That previous one, what is the difference? Is there any difference?
Difference.
Is there any
I don't
difference
know.
between arguments name? Oh, arguments name should match. See, this person gave like address T, right? Data T. Here address
Mm-hmm.
data. Okay. Here address data. That is the difference. Okay. Type def classes. Okay. Definition classes. These are type def class is used to provide forward declaration of the class. In some classes, the class needs to be instantiated before the class declaration. These kind of situations, type def class is used to provide the forward declaration of the class. Forward declaration of the class. Class C1, C2C using class C2 handle before declaring it. Class C2, C1, C1C. So it will throw an error. C2, before this, it is not declared. So before declaring it only, he is using the handle. So it will throw an error. The unexpected token C2 inventor test bench. So to avoid that one with the type def, the same thing, we will use the type def class C2. Okay. Now we will run. It won't throw an error. What is the problem? You have to type def, right? Why it is throwing an error? Maybe this simulator problem. This is how you need to get output. Simulator problem. Inside typed of class, this should come out. Randomization and constraints. Very, very important. With this, you can complete the 80% of the course. For SV, for UVM still is there. SV 80% of the course will be completed with the help of randomization. In randomization means what means? What we will do is we will take the handle of the class and we will randomize the number and we will pass on to the next class. This is it. In this pre-randomization, randomization, post-randomization, these three things will be there. Constraints. What is meant by constraints means we will put some constraints on the randomization. If we want, for example, random numbers should generate from random number, any number can be generated. But what we will do is we will put a constraint that 50 to 100 numbers only I should get give it to the my DUT. That is called constraints.
Okay. Okay.
Randomization can be done by with the help of PRNG, pseudo randomized generator. Okay.
Okay.
Variables declared with the rand keyword are standard random variables. Okay, their values uniformly distributed over this range. Rand keyword we need to use. Okay, if we want to randomize. Randc means rand cyclic. For the variables declared with the randc keyword, randomization variable values don't repeat a random value until every possible has been assigned. For example, uh, 10 random number generates 1 2 3 4 4 5 like that. Same numbers if you don't want to generate. Actually we don't want to generate. For a simulator we are giving values, right? Those values are rancy values only, because same value if we give twice, what is the use for a DUT to
Yes.
check? Here first what we need to create is we need to create the object first. After that randomize it. It will randomize. Randomization example. See here,
Okay.
class packet. In packet, ran C, address 1, address 2. After that, ran methods, initial begin. Packet equal to PKT. PKT equal to new. Repeat 10. Repeat 10 means what? 10 times it repeat, right? Packet dot randomize.
Yes.
That packet dot randomize 10 times it repeats.
Okay.
See, rand C value will not repeat. Rand value will repeat. Rand C is given for address 2. Rand is given for address 1.
Rand will repeat, Rand C will not repeat.
Yeah. Five, 3, 2, 7, 5 again. See, here also one 5 is there. Here also 5 is there. Here
Mm-hmm.
see, nowhere repeats even a single time. Array, it also repeated 5, 5.
Yeah. Yes.
Why? Yeah, it repeats. Okay, I'll do one thing. See, what did you understand by 2 down to 0 means what? Hello?
Hello.
2 down to 0 means what did you understand?
Well, 2 down to 0.
Hmm. 3 bit, right?
Random value, taking random. Yes,
No,
3 bit.
apart from random value, you see this 2 down to
Yeah.
0 means 3 bit, right?
3 bit, yes.
2 power 3, 8 combinations only you will get, right?
Yes.
If we increase this, for example, 3 down to 0, okay? Then it won't repeat, I guess.
Okay.
Because
Let's see.
4 bit means 15, right?
Yes.
See, now it won't repeat.
It's not repeating.
Why?
Mm-hmm.
Because means that numbers are completing. Only 8 numbers. So ninth number, 10th number, it has to repeat from previous value only, right?
Right.
That's the thing.
Mm.
Disable randomization.
Mm-hmm.
The variable declared with rand or randc will not get random values on randomization. What if for some reason it is required not to generate a random value for the random variable? Yes, it is possible to disable the randomization variable by using system like keyword ran mode. Okay. Randomization without randomization disable. We want with randomization disable. Randomization for a class variable. Rand mode 0. Okay, randomization. It will stop randomization. Disable randomization. Okay, we'll see this one.
Okay.
Can you see this rand mode 0?
Mm.
End mode is also available. See, address rand mode equal to 0. Data rand mode equal to 1. Okay.
Okay.
Randomization methods. Pre-randomize, post-randomize. Pre-randomize, pre-randomize and post-randomize methods. On calling randomize, pre-randomize and post-randomize functions will get called before and after the randomize call respectively. Okay, users can override the pre-randomize and post-randomize functions. Pre-randomize function can be used to set preconditions before the before the object randomization. For example, users can implement the randomization control logic pre-randomization function so that randomization enable disable by using rand mode. Post randomize is also used to check and perform post conditions after the object randomization. For example, users can override randomized values or print randomized values from the post randomization. Implementing pre and post randomized methods. See here. Function post randomization method. Okay. Pre randomization. These methods can be overridden also. See inside pre-randomizer, inside the post-randomizer. It is executing. Randomization control from pre-randomized methods. Okay. For example, assuming write read equal to 0 read operation, write read equal to 1 write operation. In order to perform write followed by the reading the same address, the randomization address controlled based on the previous randomization address value. Write read. This controlling is done in pre-randomized function. Okay.
Okay.
Class packet rand bit 7 address and ran c ran c c bit this is also write read bit temp write read temp if temp write read equal to 1 address dot rand mode 0 randomize disable. This is pre-randomized function disable randomized address if the previous operation write. Okay, address dot rand mode 1 end functions. Okay, post randomization function store the write read value to temp write read and stay randomized values to the uh, address and write read functions void post randomize tempo write read display. Okay, we will see this initializing repeat four times. It is repeating post randomization. Address 1D, write read 1, address 1D, write read 0, address 3, write read equal to 0, address 77, write read equal to 1. So it is changing write read function. If it is write read equal to 0, then it is write read equal to 1, then it is read. Constant random. Time is completed. Okay, you take 10 minutes break and shall we connect again? Hello?
Okay.
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 We'll come at 12:50.
Uh,
Okay.